Hey, it's Keith with Yarbrough Sons, and I'm here to bring you a great unit. We talk about these all the time. Definitely the DIY sweet dream and the service tech's worst nightmare. These units have come into a lot of popularity because of their ability for you as a homeowner even to be able to put them in. A lot of people do that. I wouldn't suggest that. There's a lot of things with these installs that definitely takes a professional to know and can save you a lot of money. But lots of people buy these all the time and put them in. But I thought I'd go through this and show you all the different components on this. And so we're going to tear this one down and look what's inside. Woo! Nice and dirty. Remember to maintain your mini split. So looking at this unit is only 3 years old. I know they were having maintenance on it, but definitely could have done a lot better on cleaning this up. Mini splits are often neglected on maintenance. A lot of times is, for one, it's put in by somebody that doesn't do this professionally, and they don't really think about how much maintenance it actually needs. These are crucial to having regular maintenance done to make sure not only that parts that could possibly fail, that are common to fail, are looked at, but also just cleaning. And all this kind of stuff is just adding to what's going to live there. That's what it really comes down to. So the cleaner you keep it, the more you're going to keep pests out of it, and that's going to extend the life of that actual unit. Yeah. Now that we all got this tore apart, let me tell you a little bit about this unit. This unit was actually installed on a customer's house. This one is actually called what we call a multi-head unit. Most of these tie into either like any kind of head unit. We call them head units. There's many different kinds you can actually pair up with these. You can have a wall mount, you can have a ceiling cassette, you can have a ducted, you can have a floor mount. I mean, there's endless possibilities on what they actually have tied into this outdoor system for your indoor. Kind of depends on what's going to meet your needs. Most common is the wall mount. You'll see them a lot of the places with these. They used to make one that was a picture frame. It was kind of a neat technology, but I guess it never really took off. I never got to work on one and kind of wish I could have saw one at one time. But like I said, this is a multi-head, and this is actually 1.5 tons for air conditioning, so it's 18,000 BTUs. With that, what happened with this customer was it was tied in with two 1-ton heads. So that's 2 tons of air that you'd be putting into that house. Well, if you tie it with a 18,000 BTUs, 1.5 tons, you're not going to get 2 tons of air out of it. You can kind of make it work. I've seen some people have it that way. Kind of works because they don't use one much. They just use this one and they use the other one for subsidizing this or that. So really they didn't need 2 tons of air then. If you have 18,000 BTUs, you're only going to get 18,000 BTUs of cooling and heating. Definitely want to make sure everything's sized right, and that's what happened with this one. So we ended up taking it out and putting in a 2.5 ton. That kind of gives them a little bit of extra BTUs just in case they can use it. Most of the time it's not going to use that. A 2 ton would have been fine, but for the manufacturers, they suggested to do the 2.5 ton, and we want to make sure we follow what manufacturer instructions are. So we put that in. They've been running great. Some of the problems that they were having before is on the hottest day and the coldest days of the year, it wouldn't keep up. And that's a common problem when you run into something like that. And if you're not keeping up during the hottest day and the coolest day of the year, there's a good chance that your unit is undersized. Definitely want to have a professional look on it if you're having any kind of problems. But let's get over and talk about this unit real quick. And I guess first where we'll start is the actual service valves. These are a little bit different than your standard unit service valves. Typically when you have a service valve, you usually have service valves on your what we call liquid side and your suction side. Now on mini splits, it does not. It will only have it on the suction side. So we can only tie our refrigerant gauges onto your actual suction. That brings up a problem with some service techs because we actually can't calculate superheat and subcooling with these units. But really not a big deal. Most people of us that have worked on these for a long time, we understand is these are crucial charged units. We need to make sure that it has the correct charge. Otherwise, you can damage this system. So anytime that we want to work on a system and we think it's low on charge or overcharged, we're really supposed to pull all the refrigerant out and actually add back, weighing in what is the crucial charge based off of the length of the line set and how much the unit is made for. So just simple little calculations. You can find it in any kind of install manual for these. That's one thing that most service techs will complain about this, but I find it's a lot better to know you have the correct charge. With these service valves, what they're actually going to do is they're going to tie onto your actual copper line. So we do that with flare fittings. A majority of these are flare fittings that tie on, which is great because you run into less problems with if you're going over here and tying in and you're welding. A lot of people don't weld with nitrogen, so that causes other kind of problems. So flares are great on these, and I'm a big fan of flares. We've been using them for years, and as long as you do it per the manufacturer specs, you won't have any problems. As you can see, we got two sets. You got your unit A, and for your unit B, some of them call it different, just 1 and 2. Kind of some other things on here is your EEVs. So this is your actual metering device. As you see on this one, we have 2. Now, what's different than this than your normal system that you see is your actual metering devices are on the outside. So one thing you'll definitely see on mini splits is you'll see your liquid line, what we'd call your liquid line, is actually covered in insulation. And that's because it has a potential to sweat, because the actual metering of that refrigerant is done out here instead of inside. So we want to make sure we protect that so it's not sweating if it's in your walls, in your attic, going through anything like that. We want to make sure that you're protected there, so it should be insulated. EEVs are great. They're electronic expansion device. That's what EEV stands for. That can actually improve your efficiency quite a bit because we have full control of this system to where we can actually calculate what your superheat needs to be with these EEVs and adjust it accordingly. That's going to make it super efficient. So great to have them on there. They are a little bit of work if you want to work on them. It takes a little bit of knowledge. It's not too much. You can find it in any service manual for these of how to work on the actual EEV for it. So from there, we can go ahead and go with some of the devices for safety. This one right here, a high pressure switch, and this one actually over here is a low suction pressure switch. And so those are just to make sure that nothing happens to your unit, that you're not running it in too high a head pressure. Let's say you had a dirty coil and we are getting it to the pressures that could cause a harm to this compressor or other components. We want to make sure we shut down that system. Same thing, we want to make sure that if there's no refrigerant in this thing, we're not going to run and cause damage to that compressor. So both of those are really devices to protect other parts, but mostly to protect your compressor. From there, we can go to the reversing valve. This reversing valve is actually what makes this a heat pump. It's normal AC unit, you won't have a reversing valve. All that reversing valve is an actual device that will reverse the flow of refrigerant. And pretty neat little device, just uses a solenoid. Typically on these are 240 volt or 110, depending on what the power of the system is. On most heat pumps for your standard units are 24 volts, but they all work the same way. Pretty great little device, makes it where it's able to do heat, and that's a big improvement. So other things we're going to look at right now, we're going to look up a couple sensors we have here to help calculate what we're actually needing this system to operate at. So whether we want to ramp it up and ramp it down, these sensors are what's going to help calculate that. Right here, we're going to actually have a thermistor, and this thermistor right here is for checking the actual outdoor air. So we want to know what the ambient air is outside and right before we're going in that coil. That way we can calculate it, and with that, it's going to take that information and take it to the control board and say, hey, I got this cold outside. I probably would suggest running about this speed. It does it with that, and then this right here is an actual coil sensor, and it actually is just reading that coil temperature, and that's going to also factor into saying, yeah, we should probably run it at that speed. Now, along with that, It's going to calculate the inside temperature. On the indoor unit, it'll have a couple sensors in there. It'll have a room temperature in there, and it'll also have a coil temperature in there. And that's going to help calculate that actual speed, which is really great. If you look at a lot of the high efficiency units that are just standard systems, they're doing a lot more. They have a lot more parts. That's one thing great about a mini split is they kind of cut it down to just a couple basic parts. And with that can make really great calculations and really have great efficiency. Over here, we're going to look at your actual compressor. This compressor is a rotary compressor. They've been around for a while, but they're really starting to pick up steam. I think in the next 10 years, you're going to find that every single compressor is going to be a rotary compressor. Great little compressors. I don't have too many problems with them. I've changed out some, but they really do just work. They're very efficient. Probably the biggest thing that you have a problem with them is they can be kind of loud, but I don't see that as a problem. They can send different harmonics. That's one reason why the manufacturers put these sound blankets on them, so that they can get rid of that sound. Now, the only negative thing of that is, well, it's a great home for little friends. So definitely one reason I would always suggest maintenance is you want to make sure that all this is cleaned up. And that's another thing is you really want to make sure that whoever you're having do your maintenance knows about mini splits. They're trained on them, because these are things you definitely want to clean up. As you can see, we got all kinds of little fun things in there. Lots of spiders. My daughter would hate this. They are not fans of spiders. I am the spider killer at my house. One thing you'll see on this compressor, and this should be on every unit. I don't know why they don't make this standard, but a lot of standard units will not have this, a crankcase heater. And that crankcase heater is going to be great because refrigerant likes to migrate below the oil level. And when it does that, it can actually push the oil out of the compressor. That is a big problem. One of the biggest problems that you will find with a compressor is, why did it fail? Most likely it was an oil problem. Next thing, and this is some can have it, some can't, is a pan heater. So obviously we want to operate these at the coldest time of the year. What's that going to do is we're going to actually have possibility of ice building up on this base. And to mitigate that is they have a pan heater. And that's a great device to kind of help. Definitely that pan heater will kick on whenever defrost kicks on, to make sure that, you know, we're not defrosting and then just freezing right here. We want to make sure we get rid of all that ice. That's a great feature that this one actually has. One great thing about Lennox is they usually have the devices I like on our units. So next, we got our fan motor. These fan motors can come on all shapes and sizes, but they're usually an ECM motor or a DC motor. I can think of a handful of times I've ever changed one out, and I've worked on a lot of mini splits. They're pretty solid fans. Not too many problems with those. Another thing on these fans that I like, whereas your standard unit, your fan's usually on top and it's blowing up top. We find problems with that, especially in the wintertime with heat pumps. You can run into problems where ice can build up on those blades, and whenever the fan kicks on, it throws it all over the coil and damages the coil. One of the great things about mini splits is they've solved that issue by having a side discharge. So that air is coming out sideways. You don't have that potential of water falling down on it, freezing on that fan, and damaging your unit. I always hate that because you could have a heat pump that was running really good in cold weather, and a lot of people will turn it on emergency heat because they're afraid of ice buildup on their fan. And I agree, I'm afraid of it, and that's what I tell my customers. I don't worry about that with this. This is a perfect unit. Questions that people have on these mini splits is, why is it better to use in a small area? In like garages and things like that, you'll see a lot of, you know, small little office. You'll see a lot of them. And really it's not that. You can use them on the whole house. Problem is price on some things. I can get a 5-ton unit that's a mini split that has multiple heads. We can run copper to each room and stuff like that. A lot of the reasons we don't see it here as much, we're not accustomed to designing those kind of systems. Definitely would love to design those systems for you. If you have it, let me know. I would love to have where I could do something like that. We have done it in many different instances, but you usually see them smaller because people are looking to use them as a subsidy kind of deal. You know, I've seen some people like they have the house, it's pretty good, but if you put a high load in it, maybe I want to have 50 people over there on Thanksgiving. Well, a mini split would be good for that kind of situation where I got all these people in my house in one room. That's a lot of heat. People put off a lot of heat. So it might be good to have a mini split to kind of cool that room down and not let your other system suffer as much. Kind of an easy, less expensive way than redoing all kinds of ductwork, upsizing a unit, stuff like that. This is a great option to give you the room to get around and not have to squeeze around the unit. Definitely something to think about. We talk to a lot of customers about mini splits, and a lot of big questions are, what's the ideal customer for a mini split? What need would you have to have it at home? And that kind of just varies. We can use it for all kinds of utilities, whether it be you build a shop and you want something you can run out there to keep it, you know, nice and cool or nice and heated in the wintertime. That's a great thing for it. Like me personally, I'm gonna get one to put in my garage. It's nice if you're having to work out there in the garage to be able to turn that unit on and have some heating and cooling. But I don't want it to break the bank. I don't want it to be, you know, inefficient to where I can't run it all the time. So with a mini split, I can put that unit in there and keep it, you know, a comfortable 80 in the summertime and maybe 60 in the winter time. And I'm not going to be wasting a whole bunch of energy with kind of like what you would see on a standard unit that I could get for close to the same price. They get a lot of bad raps because we as service techs don't know how to work on them. And that's a training issue. And that's one thing at Yarbrough Sons we love to do is we want to train our guys to be the best they can. So part of being the best they can is working on these units because we work on a lot of them. And I want to make sure that our guys know what they're doing. And that's going to be a lot less frustrating for you as a homeowner and our techs. And that's always been a big problem with these is guys go up to them and they go, oh my goodness, look at all this wiring, look at this board, look at this. It's very simple technology. And a lot of the problems is understanding. As a homeowner, yes, lots of people put these in by themselves. And the industry has made this where it is simple to install. Now, to work on them, that's where it gets hard. But it's not hard. It is something where if you know what you're looking at, it's not hard to fix at all. That's going to definitely come in the future. And as we get better, we're going to see more and more of these because of the savings on size. You're going to see a lot more people look into it. And if I have anything to say about it, I'm definitely pushing more of this kind of style of design as opposed to what we've had traditionally. It makes more sense for you as a customer and it makes more sense for us as a company. So, heat pumps. Is the hype real? Is the juice worth the squeeze? Yes, I have been in this industry for 20 years now. And I can tell you when I first started, heat pumps were, oh man, it just wasn't there. Especially when I started. It wasn't what they promised, let's say, and they were working on it. Definitely those heat pumps were better than the heat pumps from 10 years before, and we keep improving this technology. So yes, heat pumps are 100% worth it. I would put one in my house. I know our service manager, he actually has a heat pump on his house. Not exactly a mini split, it's just a standard one, but there is so much talks about heat pumps today. And it can get kind of overwhelming because everybody tells you great things about heat pumps. I can tell you the negative things about heat pumps, and I'm not afraid to tell you. My only big negative thing right now on heat pumps is the way air flows. We run into all kinds of problems where homeowners get a heat pump, and the one thing they don't like is they reach up to that vent and they go, it's blowing out cold air. And it's not blowing out cold air. Sometimes they'll be blowing out about 95, 92 degree air, and that is a problem. Not necessarily for the homeowner and not necessarily for the unit. It is a problem with our industry. We need to make sure that we're training our guys to know how to combat things like that. If you are reaching up and filling your air, that's not the way to do it. We want that air to circulate in the room. If you have a vent that's blowing on you, that's definitely something we need to look at. Maybe we need to put a different grill there or something like that. Anytime a human feels air that's lower than 98 degrees, they're going to feel like it's cooler air coming out of the vents, or it's not hot air. But that's not true. There can be heat in that air. 95 degrees is definitely hotter than 75 degrees. So we're definitely heating that house. So that's definitely a problem. One of the biggest things I love about mini splits is you don't have that problem. Since we have a sensor inside that is actually on the coil telling what the temperature is, it does not actually have the fan blow until it reaches a certain temperature. So coming out of this unit, coming out of the air stream, is not going to be 95 degree air. It's going to be a lot warmer air. And that is one of the benefits of having a mini split, is we have that technology to combat what you would usually see on a standard heat pump system. So love this technology. They keep improving it. Really want to see what they're going to do in the future. So, okay, so next component we have is the actual controls. Whether it be a 2-board system, a 3-board system, or a 1-board system, we'll kind of go over what you really kind of see. Most systems are getting to where they have just one control board for everything. With your controls, you're going to actually have a PCB, which is just a printed control board. That's definitely an important unit. You'll have actually a PCB inside too, and those two will actually communicate with each other and along with the other boards. They're kind of the main communicators, and they're taking all the sensor information, and that's how it's deciding what it needs. From there, that PCB on this outside is actually going to send it to a board called an IPM, which stands for Intelligent Power Module. That actual board is to actually control the compressor. Now you can have a separate board sometimes, but usually it's tied in with this system, with that one of the boards, and that will control your actual fan motor. This system right here actually has all of it together. Now, talking about that IPM, like I said, what we're doing with this compressor and what that IPM is actually doing is it is taking a high voltage AC current coming in, and it's converting it to a DC. And from that DC, we're going to manipulate to where we can actually have like a 3-phase AC current going to the compressor. So with that, when we can change the frequency, we can actually slow down and speed up that compressor. So that's where we get our savings on it. So it's a very important board to have in there, and makes this technology where it's very efficient. So whether you have a 2-board system or a 1-board system, you kind of need to know what they're there for and what's the purpose, so you can diagnose it. Another thing on this, you'll actually see it on the IPM, is a heat sink. Now, systems do it differently. Some of them are doing it where they have an air-cooled heat sink, and some of them actually use the refrigerant line as a heat sink, which is kind of a nice little technology. This one actually uses the air. Air heat sinks have been around forever. I don't ever have any problems with them. I like the air one. I like the other one too, but air's great because all you got to do is clean it off, and it usually works really good. So that's pretty much most of the components on here that I could think of. I hope this helps on making a decision on, would you like to see one of these in your house? Definitely let me know in the comments if there's anything you have questions on. We'd be happy to answer them. Definitely, if you need any kind of help seeing what you need for your house and what you need for your business, give us a call. We have technicians that can help come out and give you kind of answers. Or if you're looking at having a quote, we can get a comfort advisor out there to get you quoted on what you could use this for. With that being said, I am Keith with Yarbrough Sons, and we'll see you next time.